Okay, here we have problem number 24. So it's basically a continuation of the problem number 22 or 23. So we have two masses. The radius are the same, but density is different. So the distance is given. They accelerate toward each other because of the mutual gravitational attraction. How far from the initial position of the center of the 20 kilogram sphere do the surface of the two spheres collide? Okay, again, so initially two masses were at rest, M1, M2. The initial distance is 45 meters, okay? And when they released from the rest, they collide, okay? And when they collide, we have to find at what distance it will be. This mass 1 from initial position. So how can we calculate it? So suppose that we take this position as x initial, okay, as the original position. And then since we know that mass 1 is smaller than mass 2, we expect that mass 2 will travel a longer distance than mass 2. Why? Because mass 1 is smaller, okay? We also know that from first equation, we know that x1, which is we have to find, plus the radius of the planet, plus second radius of the planet, and this x2 distance gives you total distance, which is 45 meters, okay? We also know that we know that radius is given, so x1 plus 2r plus x2, 45. So from there, we know that x1 plus x2 gives you 44.7 after calculating it. Now, we have mathematical proportion, okay, also applied in physics, where x1 divided x2 is basically also equal to the m2 divided by m1, okay? So it's basically this one, x1 times m2, x2 times m2, which actually when object 1 travels, if it's a long distance, that means mass is smaller. And if mass 2 is greater, then it will travel smaller distance, okay? So by using this equation, we can say that x2 is equal m1 divided m2 times x1. So from here, so you take from equation 2 x2, and then you plug it here. By plugging so, you can find that your x1 is equal to the 7.56 meter.